Hi everyone, welcome to Unit 2 Radicals and Rationals. This is our first lesson. We will be talking about the radical function and transformations of a radical function. So what is a radical function? Again, just a reminder, it is this symbol right here where you have n as your index, that's always that small number inside, and m as your radicand. By default, most times if n is not listed, our index will be an index of 2, so that means we're working with this square root symbol. Just as a quick review, here's our transformation equation right here, where you have A, B, H, and K being all your transformations. A is still your vertical stretch by a factor of A. B is still your horizontal stretch by a factor of 1 over B, meaning you have to pull it out. Once you pull it out of the equation, you're going to reciprocate your B value. H is still your horizontal translation, and K is going to be your vertical translation. So you're moving things up and down with K, left and right with H. And again, reminder, with your h value, once you pull it out of the equation, it's going to be the opposite sign in the descriptor and in mapping. In terms of our radical function and the transformation for it, a, b, h, and k are all in the exact same spot. There should be no difference in position for a, b, h, and k. The only difference here is instead of saying f for function, we know our function is the radical, so we're going to switch f for the radical symbol. In our first example here, we have the radical function and we're doing a few transformations to it. We're just going to start off by trying to figure out what's happening to all our domain and range. One easy way to figure this out is if you use your graphing calculator and you type these all into your graphing calculator, we'll be able to see physically our domain and range. So for my first graph here, I have f of x equals square root of x. I want to figure out the domain and range for it. So I'm simply going to type into my y equals square roots of x, and this will give me a visual representation of my graph, and here we go. So there we go, we have our graph. So our domain looks like it's starting from 0 going off to infinity. Range is starting also from 0 going upwards towards infinity as well. So going back to my domain and range here, the way that I'm going to write this is I can either use interval notation or set notation. Both would work. In this case here, I'm just going to write everything in terms of interval notation as there's less chance to error out. So as mentioned, our domain was from 0 going off to infinity. Ooh, and where's my pen? There we go, from 0 going off to infinity. And of course, reminder that whenever we have infinity, it's going to be the rounded bracket. And with 0, we want to include that in our answer, so it's going to be a square bracket. Our range was, the lowest was from 0 going off to infinity as well, going upwards to infinity. Transformations, there should be none, as this is my original graph. In my next graph, I have f of x equals square root of x plus 3. Well, of course, plus 3 was a horizontal translation, so I'm going to quickly write that down. So this one here, we have a horizontal translation before I figure out any of this. Horizontal translation, 3 units. And of course, if it's plus 3 inside my function, it's going to be 3 units to the left. And there we go. And of course, if I'm moving things to the left, it should only be affecting my domain here, not my range. But just to double check, I'm going to go to my graphing calculator to type this in. So again, y equals, I have my x, then I'm going to go plus 3, all within under the radical still, hit graph there, and there's my new graph. So clearly we saw our graph shifting 3 to the left, so my domain is now from negative 3 going off to positive infinity, and my range is from 0 going all the way up to positive infinity. So going back here, we have our domain from negative 3 going off to infinity, positive infinity, and our range was from 0 going off to positive infinity as well. In this next example here, we have square root of x minus 4. Notice that our radical symbol stopped after x. That minus 4 is outside of the function. So if you're outside of the function and you have a positive or negative, that's a vertical translation. So I have VT for vertical translation. We're going 4 units. And in this case, because it's a minus 4, we're going to go 4 units down. And of course, if we're going 4 units down, that should only affect our range, not our domain. But again, let's graph it out to double check. So here I'm going to just quickly type in my equation. So there's my root x. And just a quick reminder, on a TI-84, as you see this cursor still blinking there, you want to hit your right arrow to get out from underneath that radical symbol and then your extra numbers after it. So my -4 after. And there we go. We have my function graphed right down here. So my domain from 0 going up to positive infinity, range from -4 going all the way up to positive infinity. So going back here to my notes. So my range is going from 0 to infinity. Sorry, that's my domain is 0 to infinity. My range is from -4 going off to positive infinity. Last but not least, we have a negative in front of the function and a negative within the function. So that means we have a reflection and another reflection. So this first one here is a vertical reflection, and this one here is a horizontal reflection. So in transformations here, I'm going to say the very first one, I work it left to right. So we have a reflection. And if it's a vertical reflection, that's a reflection on our x-axis. Then up next, we have a reflection, because it's a horizontal reflection, on our y-axis. And again, I just want to double check what my domain and range is. I already have an idea. It's most likely going to be in reverse order, but here we go. Let's just do a quick check. Again, in an example like this, use your negative button on the bottom here and not your subtraction button. You'll get a syntax error if you do subtraction. So I have negative square root of negative x. There we go. Hit graph, and that's what we get for our new domain and range. So my domain is going from negative infinity all the way up to 0 there, and it stops at 0. And my range is from negative infinity going up all the way to 0 there as well. So I have from negative infinity going up to 0, including 0 for domain, and from negative infinity going up to 0, including 0 for my range. On the bottom here, this is just asking you to sketch out all 4 graphs. The very first one is done for you. So all we have to do is sketch the other 2 graphs on here as well. Or sorry, the other 3 on here as well. So I'm going to quickly pause and sketch all 3, and then I'll show you what it's going to look like. And here you go. All 4 graphs are now sketched on here. Just an FYI, this is what I did. All I did was I sketched the original in blue and I color coded all the rest. So I'm just shifting things either left. In this first one was left 3 units, the second one was down 4 units, and we did a double reflection on the last one there. So the easiest way to do this, as an FYI, I just plotted my coordinates and connected the dots. You could also graph this on your graphing calculator and then copy the same coordinates over as well, and it should work out as well for you. In our next example here, so we're doing a bit more transformation work. What we're doing is we're going to compare everything to our radical root x there. So we're going to start off again with our domain and range to see what that's going to look like. And again, for my domain and range, I have 2 options to write down my domain and range. I can either use set notation or interval notation. And again, I'm going to just choose to do this in interval notation. Both are absolutely fine, but I'm just going to use interval notation for today. So my domain, of course, is going from 0 going off to positive infinity. My range is also from 0 going off to positive infinity. Here I want to figure out some of my transformations before I figure out my domain and range. So here we go. So first off, I see this y minus 2. I definitely don't like how that's set up. I'm going to move that minus 2 to the other side. So I have a new equation of y equals this radical symbol negative 1/3 x inside the radical. All of that is going to be added by 2 plus 2 at the end there. So going left to right in terms of transformations, I see a negative sign there, so that's a reflection. And this time it's a reflection within the radical symbol or within our function, so it's a reflection on our x-axis, or on our y-axis, y-axis. We have that 1/3, that's my b value, so that's a horizontal stretch by a factor of, and hopefully you got it, it should be by a factor of 3 if you reciprocated that 1/3. And that 2 at the end there is a vertical translation, and so we're going up 2 units, so 2 units up. And again, I'm always going to go, once I have an equation, I'm always going to my graphing calculator to double check what the equation looks like, and then to figure out my domain and range after that. So here I have my graphing calculator pulled up, so I'm just going to type in my equation. So my equation is square roots, and I'm going to have my negative sign. Reminder, use negative, not subtraction. I'm going to build my fraction using alpha y equals, and this is going to be 1/3 x. And then after that, hit the right arrow to get out of the radical plus 2. There you go. And I'm going to hit graph right away. And there we go. We have our equation or our graph right there. So we're up to, we have a horizontal stretch by a factor of 3 and we are reflected. So my domain on this one is going from negative infinity all the way up to 0. My range is from positive 2 going up to infinity there. So my range or domain first is going from negative infinity all the way up to 0. And my range is starting from positive 2 going all the way up to positive infinity. In this next example here, we have minus 2 square root of x minus 1. So again, I'm seeing 3 different functions happening here. So I'm going to write down all 3. First off, I see the negative. So I'm going to deal with that negative first. That's a reflection on. And again, if it's on the outside of my function, that's going to be reflection on our x-axis. That 2 is outside of the function, so that's a vertical stretch by 2, by a factor of 2. And I have that minus 1. That minus 1 is on the inside, so we have a horizontal translation, 1 unit. That's 1 unit to the right if it's a negative inside the equation there. And again, I'm going to graph this out on my graphing calculator to see what it looks like before I attempt my domain and range. So I have my minus 2 roots x minus 1. Hit graph once I'm ready. There you go. That's my new graph. So again, my domain here is starting from 1 all the way up to positive infinity, and my range is going from negative infinity all the way up to 0 there. So my domain, as mentioned, we're going from 1 all the way up to positive infinity, and my range was from negative infinity going all the way up to 0, including 0. And again, I want to graph out both of these on the bottom here. There's my original, that's my y equals root x right there. That's my original, and I want to graph out the other two. And so I'm just going to pause the video. I'm going to graph it out and then come back and show you what it's going to look like. And here we go. I have all or our new 2 graphs graphed for you, and this time I included some coordinates just to help you out. So on our original, I was able to plot 0, 2, negative 3, 3, and this one over here I'm totally guessing, but negative 12, 4 should be off the grid and it should be off to the left there. On our last graph here, I'm starting off at 1, 0, 2, negative 2, and 5, negative 4, and again, I'm just connecting my dots, and that's where I get for a graph. On this next example here, part B of the same 2 questions is asking you find the x and y intercepts for the 2 functions above. So I'm going to work with one equation and then the other. So let's start off with our equation of square root. So this is y equals square root of negative 1/3 x plus 2. That's the equation I'm going to start off with. To figure out my x and y intercepts, and again, just an FYI, just a quick note, x-intercepts means you want to set y equal to 0, and y-intercept means you want all x to equal to 0. So you have 2 scenarios that you're going to have to sub into this equation and then solve. So x-intercept first here. So I'm subbing in 0 for y, so this is going to be 0 equals radical negative 1 over 2, or sorry, 1 over 3 x plus 2. So moving the 2 to the other side first, I have minus 2 equals radical negative 1 over 3x. And from here, if you notice that there's a negative inside your radical sign here, so this negative times x, whatever x is, won't actually work. You cannot square root a negative value. So therefore, on this first graph here, we're not going to have any x-intercepts because you can't square root a negative value. So cannot square root negative value. So, and that does match up to this graph here, and I'm just going to quickly show you which one that was again. It's this guy here. And again, if you take a look at this graph here, nowhere are we near the x-axis here, so there's no x-intercepts. We definitely have a y-intercept. It does intercept on the y-axis there, and so that's what I'm going to try to find. So for the y-intercept, I'm going to again set my equation, but this time x equal to 0, so I got y equals. So there you go. I have my equation all filled in, subbed in 0 for x there. 0 times negative 1/3 is still 0. Square root of 0 is 0. All of that kind of disappears. So I have y equals 2. So there you go. I have a y-intercept of 0, comma 2. And that should be my ordered pair for my y-intercept. On our next equation was y equals minus 2 root x minus 1. And again, just a quick graph just to double check what that's going to look like. I'm going to clear off these guys here again. So I got minus 2 root x minus 1. So again, there's my graph. Again, I should have a x-intercept here. It's crossing our x-axis, but notice that because we shifted it to the right, we're away from the y-axis, so I'm expecting nothing for my y-axis. No answer there. So to find my x-intercept, I'm going to sub in 0 for y, so I'm going to start off with x-intercept. So I have 0 equals minus 2 square root x minus 1. To move off this negative 2 to the other side, I divide everything by negative 2. That doesn't affect anything. Up next, I'm going to square everything to get rid of that squared. So again, 0 squared. And in this case here, we're going to square. 0 squared is still 0. It doesn't affect anything. And our square root symbol goes away. And to isolate for x, I'm moving that 1 to the other side. So I have 1 equals x. Therefore, we have a coordinate of 1, comma 0 for our x-intercept. For our y-intercept, for the exact same equation, again, there's the reminder of your equation. For our y-intercept, you're going to substitute in 0 for x. So I'm going to set up this equation as y equals minus 2 square root of, and I'm subbing in my 0 there, minus 1. So I got y equals minus 2, and inside this radical, 0 minus 1 is just negative 1. And again, I see a negative inside the radical. You can't square root a negative. So therefore, no y-intercept. And again, that does match up with this picture here. We were shifted away. There should be no y-intercepts based off of a graph. And up here, I should have finished this one off with, therefore, no x-intercepts. There we have it. Moving on. So we're going to talk about mapping notation really quickly here. Mapping notation is still the same as before in our transformations unit. So if you had xy original and you want to map it out, you're still going to have to reciprocate your b value. So again, this is either 1 over b or x divided by b, however you want to write that. It's going to be reciprocated plus h, comma, ay plus k, and again, a is your vertical stretch there affecting your y, k is your vertical translation, h here is your horizontal translation. So if I wanted to map these out, the very first thing I need to do is rewrite this equation. I need to get a b value by itself, and the way I do that is I'm going to factor. So I'm going to quickly rewrite this equation here. I'm going to factor out that 5 there within the bracket, so that's 5x. 5 times x gets me 5x, and 5 times should be negative 3 to get me back to 15 there. All of that is under the radical symbol and then the plus 2 at the end. So what does that mean? What do I have here? So I have a reflection on our x-axis here. We have a horizontal stretch by a factor of 1/5, horizontal translation, and a vertical. So what's going to happen to my mapping? So let's rewrite out our mapping. So again, we have a negative sign, it's just a negative, and I'm just going to quickly jot a few little notes underneath. So that's a reflection. This is a horizontal stretch, horizontal translation, and of course a vertical translation. So just gonna label things to plug in to my equation here. So if I have a horizontal stretch of 5 in the equation, that's a horizontal stretch of 1/5 in mapping or in descriptor. So again, that's 1/5. It's gonna be 1/5 x. And if it's -3, that means I went 3 to the right, comma. I have no stretches on y here, but I do have a reflection, so it's going to be -y plus 2. There we go, and that's my new mapping. For my coordinates here, I just substitute 1 and 1 in for x and y, and I end up with the following. So 1 times 5 is 1/5 plus 3, and of course that 3 you should change to 15/5. This is now 16/5, and of course I'm going to try to my best to keep it as a fraction rather than a decimal. Fractions are just a bit easier to work with. In this case here, it was -1 plus 2 is still +1, and we're done there. 9 and 3, we're going to sub in, and again, you're going to get some ugly fractions here, so that's 9/5 plus 3. Of course, I go straight to my calculator. I'm going to get 24/5 there, and this 3, we're going to sub in, so that's -3 plus 2 is -1. So those are my new transformed coordinates. Over here, again, I still need to rewrite this second equation here. I need to move this 2/3 away from y. So the way I do that is I either divide it off or multiply by a reciprocal. So I'm going to choose to multiply by a reciprocal. So this is 3/2. This is now my vertical stretch on the outside of my function here. Inside my function here, I see a -x minus 4. Again, I don't have a dedicated b value. I'm going to get a dedicated b value by itself, -1 there. So that leaves me with x plus 4. I have to flip all the signs there. And there we go. We have my equation all isolated. So here I have a vertical stretch. I have a reflection. And I have a horizontal translation. And this reflection is on our y-axis, by the way, because it's within the function. So my mapping is going to end up being, so bracket, my mapping is going to be -x, because we're reflecting it on the y-axis, so that's a horizontal reflection. Plus 4 means we went -4 units to the left, comma, and we have our vertical stretch 3/2 y, close bracket. And again, I'm going to sub everything into this mapping notation here. So if I sub 1, 1 in, I'm going to end up with -5, comma, 3/2. And down here, I'm going to sub 9, 3 in. So 9, 3 is going to get me to -13, comma, 9/2. And there we go. In the next example, example 4, all we're doing is trying to write down our equation for this new transformed function here. So just an FYI, our original function should have been, and I'm going to graph in my original, so 0, 0, 1, 1, 4, 2, and 9, 3. This might help you figure out if you have vertical or horizontal stretches, by the way. That's why I'm graphing in the original versus our new one that we already have on screen there. So let's talk about what I see right away. So I'm always going to check for vertical stretch right away. So the order I should be checking things in is RST, by the way, reflection, stretches, translations. I don't see any reflections because it's not changing direction and it didn't go over here in quadrant 2. So there's no reflections in this one. So the next thing I check is stretches. The first one I check is vertical. I do see a vertical stretch. It's going to be a stretch by 3. So how do I know? Between the first two coordinates here, this is a distance of 1. These two coordinates is a distance of 3. To go from 1 to 3, it had to be a vertical stretch by a factor of 3. Do I have any horizontal stretch as well? From 0 to this first coordinate here, that's just one square wave difference. From this one here, this this new graph here, to its first dot here, the x distance there is also one way, so there's no horizontal stretch. I do have a transformation going on here. That's 4 to the right, 2 up. So we have a horizontal translation, 4 units right, and a vertical translation 2 units up. And putting it all together, this is what I'm going to get for an equation. I have y equals 3 square root of x. If it's to the right, it's going to be plus 4. And then, and I made that a bit too long. Then I want a plus 2 there at the end. And there we go, that's my equation. But here, notice that it says to write our equation in ax minus h plus k form and in b x minus h plus k form. So now I got to rewrite this exact same equation that I just wrote here with this 3 inside the radical. Well, to move this 3 inside the radical, all you have to do is square it. So I'm going to end up with 9 x plus 4 in brackets there because we're not changing anything there, plus 2 at the end. So to go from this 3 on the outside to a 9 on the inside, or from a 9 on the inside to a 3 on the outside, you had to square root 9 to get to 3, or go 3 squared to get to 9, and there you go. That's how you go from one direction to another. On this example here, again, I'm going to double check my original versus my new here. So I got 0011 4293. That's my original function. Running RST on this, I definitely have a reflection. It was reflected over your x-axis there. I have a vertical stretch. Again, I have original vertical stretch of 1. Over here on my new graph, it's a distance of 1, 2, 3, 4 away. So I'm going to write down a few things. We have a reflection on y-axis, or sorry, on our x-axis. A vertical stretch by 4. And it looks like we moved it 2 to the right and 3 up. So we have horizontal translation 2 units right, and a vertical translation 3 units up. Putting this all together here, we have y equals negative 4 square root of x minus 2, so that's the movement of 2 to the right, plus 3 up. And again, if I want to get this 4 inside, not the negative, that negative is a reflection, don't worry about the negative, just the number. If I want to get that 4 on the inside of the radical, I'm going to make that become 16, because the square root of 16 is 4. And there you have it. You have your equation written in 2 different formats. So moving on, we have our next set of examples here. And so this next example here and the last one is purely all calculator work, more or less. So make sure that you have a graphing calculator out with you and you're able to type stuff in. So in this case here, we have near the surface of the Earth, the velocity of sound, sound in air in kilometers per hour is approximately related to the temperature. So what do we want to do here? We want to first, in part A, it's telling you, well, I gave you an equation. What you want to do is set up your window settings. So that's what this little square bracket means here, is it's wanting to know what your window setting is that you use to graph this equation here. I'm going to have my graphing calculator up here and type in this equation. So my equation is going to be 72 radical symbol. X is going to replace t there because that's our only variable, 273. And if I hit my window setting right now, this is my standard window setting. If I hit graph, do I see my graph? I don't see anything, so I definitely need to play around with my window setting. And so what you want to do is you want to make things bigger. until you do see it. So basically a good trick is to add on a 0 everywhere and then see what happens to our window setting. See if we can see anything, and then from there we're going to adjust. So again, if I hit graph, I still don't see anything, so I'm going to make it even bigger. So and again, of course, if I have a shift to the right of 273, or sorry, that's to the left of 273, I know I probably need a x minimum bigger than 273, so I'm going to do something wild like negative 500 there. Gonna go up to, let's say, 1,000, and let's go up by 100 just to see our window setting. And here, because we didn't see any y values yet, I'm still gonna go up to 1,000 there, go up by 100, something wild. And let's see, there you go. We do see part of our graph. And so now I'm just gonna focus in on my graph a bit more. So I'm probably gonna want more y's because I don't see the top, I don't see it starting to curve. So I want more y values. So again, we probably don't need so many y negatives. Let's go to 2000, see what happens this time. And there we go, we start seeing our graph curve, and that looks pretty good. And so that's what I'm going to use for a window setting. So again, here's my window setting that I'm going to copy down. So again, whenever you see a square bracket like this, you're just jotting down your window setting. So I'm using negative 500. And then we went to x max of 1,000 going up by 100. So 1,000 going up by 100. And my y values, I'm going from negative 10 to 2,000 and going up by 100. So negative 10 to 2,000 going up by 100. There we go. And we were able to see our graph. And that's all that this first question was asking you is, are you able to play around with the graphing calculator to see what it looks like? In part B is asking you what transformations have occurred. Well, that 72 is a vertical stretch, so I'm going to write down vertical stretch by a factor of 72. And of course, we have that 273, so that's a horizontal translation, 273 units to the left. What's our domain and range here? Well, let's take a look at our graph. So our graph is starting as far left as negative 273 and going all the way right for my domain. So my domain is going to be from negative 273, and you had to include 273 going off to positive infinity. And my range, it looks to be from 0 going up to positive infinity there. So from 0 up to positive infinity. In part D, it's asking you the hottest day recorded was 36.1 in 1919. Find the velocity of sound at this temperature. So we're looking for 36.1 on my calculator. So all I'm going to do is if I hit my trace button and type in 36.1, because that there should be my x value, hit enter. There we go. You get a y value. It's 1265.84. So I'm going to say x equals 36.1. Y has to equal, and this is straight calculator, 1265. And that was 1265.85 technically. Oh wait, it says to round to the nearest kilometer, so this is 1266 kilometers for our y value with a temperature of 36.1 degrees. And for part E, and again, that was straight graphing calculator. And again, what did I do? I hit my trace button and typed in 36.1 and I got my Y value. For part E, it says the coldest day, the sound was traveling at 976.655 kilometers per hour. What's the temperature? So on this one here, you're going to do two things. So the very first thing you're going to do is go back into your equation here and type in that speed there. Type in that 976. So 976.655. You can type that in as a y2, and you're going to see a line or something cross on your graph here. And so let's just hit graph to see what that looks like. There you go. There's my temperature, or sorry, that's my speed. And I'm looking for that intersection there to figure out my temperature. So I'm going to go second trace, option 5. And I'm just going to bring my cursor as close as I can to where those intersections are and hit enter 3 times. So 1, 2, 3. And there you go. At y equals, so we're going to start off at y equals 976.655 exactly. We get x equals, and going back to my graphing calculator, x equals negative 89 degrees Celsius. And again, straight graphing calculator and how we did that. You could solve this one algebraically, but you can do it graphically. It's much faster. For this last one here, more or less the same thing. I gave you a function. I'm asking you to write down the function, write down domain and range, and find x and y intercept. So again, we've already done x and y intercept. So let's quickly go through this last one here. So I see a negative, so that's a reflection. And again, I always work left to right, reflection on my y-axis. I see the 1/2, so that's a horizontal stretch by a factor of 2 as you reciprocate that fraction out. I see and sorry, I'm running out of space, horizontal translation 2 units right. And I see a vertical translation 5 units up. There we go. And to determine our domain and range, again, I'm just going to graph it. It's always easier. I'm a visual person. I like to see what I am doing. So here we go. I clear off everything. I have my negative, radical symbol, building my fraction now. Again, you could build your fraction or use 0.5. It's the same thing. Whatever you want to do. I'm just going to build my fraction x minus 2, close bracket, 1 to the right to get out of the radical symbol. And then we're going plus 5 to this guy. Graph. Oop, and I forgot to change back my window settings, so zoom 6. And there you go, there's my graph there. So it looks like we are as far right as 2. We're going from 2 all the way up to infinity, and as high as 5 going down to infinity. So my domain is starting off at 2 going up to positive infinity. And my range was starting as low as, technically, sorry, that's a rounded bracket, as low as negative infinity, and we went as high as the number positive 5 there, including 5, so it's a square bracket there. To figure out my x and y intercepts here, one of two things. I could take a look at my graph here and I can definitely figure out my x and y intercepts, or I can solve it algebraically. So again, x-intercept here, meaning that you're looking for y equals 0. So in this equation, any y I see, I'm going to sub in 0. So I'm going to rewrite this equation as 0 equals negative 1/2 x minus 2 plus 5. And I'm going to solve this one algebraically. So that's minus 5 on this side. I move that 5 over. Up next, I'm going to move this negative, technically it's a negative 1 to the other side there, so that's a positive 5 now. Here, I'm going to square both sides to get rid of my radical symbol, so squared squared. So that's now going to be 25 equals 1/2 x minus 2. Get rid of that 1/2 by multiplying it by 2. Sorry, it shouldn't have been this guy here. Get rid of that 1/2 by multiplying everything by 2. So now that's 50 equals x minus 2. And get that 2 away from it. So we have x equals 52. So we should have an x-intercept at 52, comma 0. For my y-intercepts, because I graphed it out, I know that there shouldn't be a y-intercept at all, but let's quickly check. So y-intercept, meaning when x equals 0. So in this equation, again, I'm going to sub in 0 for x, so I have y equals negative square root 1/2 bracket 0 minus 2, close bracket, and you have the plus 5 on the outside there. So I'm going to quickly clean this up. This is y equals, sorry, just give me 2 seconds. Sorry about that, folks. Just to finish off this last question here, again, I'm just going to simplify and clean up this equation before I was slightly interrupted. I'm going to have a negative sign still here. This 1/2 is going to be multiplied by 0 minus 2, which is really negative 2 times a half, which is now negative 1, plus 5. Well, notice that I have just the number under this radical symbol. That number is a negative. You cannot square root a negative number. Therefore, there's no y-intercept. All right, and that's the end of our lesson. If you have any questions, please feel free to ask.